Alright, next we'll be moving on to the binomial theorem for rational numbers and negative numbers. Over here, Q just represents rational numbers. Again, this is in the formula booklet. A plus b to the power of n, where n, again, is either a fractional index, like half, or like a negative index, like -1, will be equals to a to the power of n, bracket 1 plus n, b over a plus n minus 1 over 2 factorial b over a square. So this kind of reminds you of NC2, right? But in this case, it's just applied to non-natural numbers. Okay, and one more thing, this expansion is only valid for when mod b is less than mod a. We'll utilize this a bit later. So let's solve a question. Find the first three terms of the binomial expansion of x over square root 2 plus x, and then state the set of values of x for which this expansion is valid. Alright, so it may not be immediately clear how we're going to use the binomial theorem. So let's simplify this. We actually get x times 2 plus x to the power of -half. Can you see that? So how are we going to expand this? Usually what I like to do is I don't like to have the 2 here. You see I highlighted the a over here. I like it when a equals to 1. Okay, so how am I going to make a equals to 1? What I'm going to do is take out a 2 here. Okay, 2, 1 plus x over 2, and then whole thing to the power of -half. And if you remember your laws of indices, you actually just get x times 2 to the power of -half, and then whole thing bracket 1 plus x over 2 to the power of -half. Alright, so if I simplify this a little bit, I'll just get x over square root 2 and then times this expansion. Now, let's actually do the binomial expansion. See, I highlighted a over here, so you can technically just ignore the a. Okay, so if we ignore the a, we'll just get 1 plus n, in this case n is -half, okay, b over a, or in this case we just do b because a is 1. What is b? b in this case will be x over 2 plus n minus 1, which is -half minus 1, over 2 factorial, and then b squared. Alright, and don't forget this whole thing is multiplied by x over square root 2, which I forgot to do. So let me just do it over here. And simplifying this, we'll just get x over square root 2. Alright, so we have found the first three terms of the binomial expansion. But next, we need to state the set of values for which this expansion is valid. So in this case, we're expanding 1 plus x over 2. So what we want is mod b is less than mod a. Mod x over 2 is less than mod of 1 because a is 1. And what we'll get over here is just mod x is less than 2. Again, reminder that this means that x is between -2 and 2. So what this means, once again, the expansion is only valid, that means we can only substitute values of x between -2 and 2. So let's say if we want to substitute a value of x equals to 3 into here, okay, it's not going to give us an accurate expansion. But if we substitute, let's say, a value of x equals to 1, if we put in x equals to 1 over here, right, from the original and the actual expansion, what you get is actually a pretty accurate answer. So thank you guys for watching. Here's a summary sheet for binomial theorem for both natural numbers and rational numbers. I hope this was useful.